Hello and welcome to part 10 of Speranza Guesses the Methods exam, the series where I guess the methods exam so you don't waste your holidays and you do some study instead. I've been busy saving the world from Thanos, but I'm finished with that now, so we can get rid of that and let's do some maths. So, Tech Active, multiple choice, question 9, give yourself 90 seconds, go. And I'm going to do it in 3, 2, 1, let's do it. It's an isosceles triangle, something like that. But it says one of its internal angles is 98 degrees. Okay, if one of its internal angles is 98 degrees and the internal angles of a triangle are 180, that means that there is only one angle that is 98 degrees. So I'm going to have to redraw my isosceles triangle. So something closer to that, where that's my 98 degree angle. I can easily figure out these two angles here. Not necessary for the question, but I can. 108 minus 90, 180 minus 98 over 2 equals 41. Not necessary. Okay, we know that the area is 60 centimeters squared. All right, this should remind us of a formula, and that formula is area equals 1/2 BC sine A. Okay, it's an isosceles triangle. These lengths are the same. This is B length, this is C length, and this is angle A here. So I can put all of this in now with area is equal to 60 times 1/2. B and C are the same, so let's make it x times x. In other words, x squared. Sine 98 is our angle. So we have an equation, we have a calculator. We can solve this relatively easily. So I'm n solving 60 equals half x squared sine 98x, 11.0081. All right, so we've n solved that. 11.01 is our answer. Now, my class, students who I actually teach, are going to be shouting at me about using n solve because I always tell them not to use n solve. The reason I feel okay about using n solve here, it's going to spit out one solution. When I look at this equation, I have an inkling that there's going to be two solutions because there's an x squared in there, and you often end up with two solutions with x squared, right? I am doing a multiple choice question, so if this spits out one single solution and that one single solution is in these options, then I feel good about that single solution. I'm pretty sure that I know that if I were to graph this, I'd get two solutions. One of those would be a negative solution, which is like a negative length, which doesn't make any sense here. So I'm using nsolve, but I'm using it cautiously. I know what I'm doing. nsolve is, I think, a very dangerous tool on the TI because it only spits out one answer when there could be multiple answers. In this case, it's not a problem. In this case, it's not a problem. Next question. Okay, last tech active multiple choice question. Give yourself 90 seconds. And I'm going to solve it in 3, 2, 1. Let's do it. All right, so before I do the question, straight up, 600 Maths Method students, only 70 of them watched these videos. Like, subscribe, share, notification, hit the bell, whatever. That number's too low. You should be telling your friends. All right, let's do it. It's a confidence interval question. Let's jump into our calculator. 60, 70, 85 are the numbers I need. All right, menu, statistics. We're doing confidence intervals, and we need this one prop z interval. Okay. Successes, all right, I've already forgotten it, 70. Number of people, 600. And the confidence interval here was 85, I believe. Okay, we've got 0.0978. 0.0978 and 0.1355. My answer here is B. If you're interested in how I came up with options A, C, and D, they're all different sized confidence intervals. So 90, 95, 99, something like that. I've purposefully chosen a very strange confidence interval here, 85%, to force you to either use this option on your calculator or to figure out what the z value is and to use that formula on your formula sheet, but not know one of those like famous z intervals, 1.64, 1.96, and 2.58. That's why this question is the way it is, but let's move on to short response. Okay, short response, 6 marks, so like 9 minutes on the clock. have a try. And I'm going to solve it in 3, 2, 1. Let's do it. Okay, this is a trick that the QCAA pulls a lot, where they tell you some new information that isn't in the syllabus. In this case, the length of a curve y equals f of x over the interval AB is equal to this weird formula here. Now, there are courses across the world where you'd learn this formula and you would be tested on this formula, in which case a question like this might be like complex familiar. But in our syllabus, we're not taught the length of a curve, so it becomes complex unfamiliar. Now, I haven't pulled this question out of thin air. It actually was a style of question, sort of, that the QCAA used. Back in 2020, they did a question that was very similar. Consider the following information, this. If you take a look at some of the past questions, complex unfamiliar questions, you see they do this a lot. In this question here, they say, oh, we've got this new style of difference of confidence interval formula that we're just going to give you, and you're going to have to now be able to use that. In here, they give us some new information about the expected value and the variance of a very special kind of probability density function. In a public mock that they handed out 3 or 4 years ago, they gave us this little box here with a bunch of information about distributions. So this kind of stunt is a stunt that the QCAA does a lot. All right, so let's move on to the question. I've got a function, and it's a funky looking kind of function. I should really draw it on my calculator before I get started. Okay, so I've sketched it on my calculator, and you can see it looks like a straight line from here down to here, but there's all this funkiness in here. So I'm not really trusting the idea that it's a straight line. So let's take a really close, there we go. If we take a closer look at our graph, we can see that it's actually like a bumpy line going down this. Let's just sort of zoom in a bit further here. All right, there we go. We were told it was a bumpy road, and when we zoom around the place, we can see that it is in fact a bumpy road. And so we're trying to find the length of this bumpy road is the idea here. So let's find out a little bit about this mountain. It might be useful to know where this intersection point is, or the 0 is. Okay, so 992 right there. Okay, it might be useful to know how high the mountain is, maybe. I'm just doing a graph trace here. Okay, 201.5. All right, so I have a rough idea now of what this graph looks like. All right, so there's my little mountain track. I'm going from a height of 201.5 down to the base, 9,992 meters across from where the peak is. So now we should be able to use that formula here to find the length of this bumpy road. So the length of the bumpy road, according to our formula here, is going to be the integral between b and a, so 9992 and 0, of the square root of 1 plus f dash of x, all squared with respect to x. And now that we know that, all remains to do is to put that into our calculator. And it's going to be a big formula, right? Because we've got this big function here that we would want to put into there. So I'm going to make my life a little bit easier by going menu, actions, and I'm going to define a function. So I'm going to define f of x as this function right here. And then just equals and type all that in. You don't need to watch me do that. All right, so I'm defining my function as, let's make sure I've written it all in correctly, yes. And that means I now can call on that function. So let's now do this formula. And that's going to make my life a little bit easier when I do this formula, I think. So I'm going to do the integral between 9992 0 of the square root, need a square root here, 1 plus and then in brackets, I'm going to call on the function f. And when we do that, we don't just type f, we type f of x. All right, so we have a function of x. We're going to square it with respect to x. And then you're probably yelling at the screen now because the equation, we don't just want f of x, we want f dash of x. So we're going to have to also do a little derivative here of x with respect, and we need that f of x not there, but we need that f of x in there. All right, so let's, looks like I've got one too many brackets here. Okay, let's look at it. The integral between this and this, that's fine. The square root of 1 plus the derivative of the function that we defined earlier, and then the derivative of that function that we defined earlier needs to be squared. Okay, good. Okay, that looks okay. That should be the length of my thing here, 10,009.4. Do I think that's correct? Well, maybe? So I moved across from 0 to 9,992. I started at a height of 201. So this length definitely needs to be longer than 9992. I'm a little bit surprised that it's so close to 9992. I would have thought that the combination of the slope and the bumps would have added more distance than that. But, okay, maybe I'm correct. I think the next part of it, though, is going to tell me whether I am correct or not. We're going to smooth out the road. So we're going to have the same thing. We're going to be going from 201.5, and we're just going to go straight down to 9992. All right, so we can just do this like Pythagoras' theorem style, right? Because we know that the length of that is 9992. We know that that is 201.5. So this is our c squared in Pythagoras' theorem. All right, and that's Pythagoras' theorem there, and in a show of complete laziness, I've gone over to my calculator, n-solved it, which I keep saying you shouldn't do if you're on a TI, n-solved it, and I've got an answer of 9994.03. Okay, that makes me feel better about the answer that I've come up with in part A, because, again, I'm quite surprised, although I really shouldn't have been, I guess. I'm quite surprised that if you go 9992 across, and 201.5 up, the length of the hypotenuse is only just this much larger than the length of the bottom side there. Okay, determine how much shorter the road will be when completed. This is really the end here, minus 9994.03. The answer is 15.37 meters shorter. All right, you can see I invented this question about an hour ago, and you can see that I didn't know whether it was working as I was talking, right? This number really freaked me out. But I kept moving and I kept checking. What I see sometimes in these sorts of questions is students just unquestioningly coming up with answers. And so they might go, well, that's they might type this into their calculator and get an answer of 1 million. Well, this road, no matter how bumpy, is not going to have a length of 1 million meters, right? Or they type this into their calculator and they get some sort of negative value and they say the length of this is negative or something. You saw in real time how my brain was processing whether this question was working out or not. And I advise you when you're doing these questions to do the same thing. Finally, I'll mention it again. This kind of trick here, where they introduce a new formula, new information, is a specialty of the QCAA. So don't be scared. You can see once you actually apply this new information to this question, it's actually a very straightforward question. And that should be the case when the QCAA does this. When they do say, well, here's some new formula that you might like to use, once you actually start using that formula, it's pretty straightforward. And it's time for the last question. Now, this question comes to us courtesy of the HSC last year. So if you have been searching far and wide for questions, maybe you've seen this one before. If you haven't, give it a crack. Give yourself 9 minutes, I guess. All right, and I'm going to solve it in 3, 2, 1. Let's go. All right, so there's a little bit of reading there. You can hopefully get the sense that what we're looking at is a combination question, something that happens a lot in complex, unfamiliar questions. What we've got here is some kind of probability density function, and then we've also got some mention of a normal distribution. Okay, now sometimes when you read one of these questions, it can get really overwhelming. And I know the first time I read this question, it got really overwhelming as well. But when I get to the end here, it says, what is the probability that this person has an IQ greater than 130? And then if I move up, I go, well, what do you mean this person? I'm reading the question backwards here. What do you mean this person? Who's this person? A person chosen at random can complete the puzzle in less than 2 hours. Oh, so when you talk about this person, you mean a person who can solve the puzzle in less than 2 hours. Okay, what is the probability that a person that can solve the puzzle in less than 2 hours has an IQ greater than 130? Okay, there is another way to phrase that. What is the probability that a person has an IQ greater than 130 given they solved the puzzle in less than 2 hours? And that's what this question boils down to. It's, at its core, a very straightforward question. It just takes a lot of interpretation. So here's the crux of the question. We are trying to find out that someone has an IQ greater than 130 given they solved the puzzle in less than 2 hours. So we need to know this thing and we need to know this thing. This thing's going to require our knowledge of normal distributions, and this thing's going to require our knowledge of probability density functions. All right, so the probability that they solved it in less than 2 hours, we're going to come up with that from this thing here. And that's going to be the integral between 0 and 2 of the function f of x with respect to x. Now, of course, I've got my calculator, so I should be able to type in this thing and just find out an answer for that. All right, coming up with that answer, pretty straightforward. It's 0.30, whatever that was. Come back, calculator. 30103. All right, we're halfway through this question now. The other bit is the probability that the IQ is greater than 130. All right, now I can kind of do that in my head actually, but let's use our calculator. I'll talk about how I can do it in my head in a second. All right, so we're going to go menu, probability, we're going to go distributions. We're trying to find a normal CDF. All right, so what do we want to do? More than 130, right? So let's go a lower bound of 130, an upper bound of 1 million, smartest dude alive. Normal distribution of 100, standard deviation of 15, and 0.02275. Now, if you noticed a small crack in my confident exterior, that's because I, in my head, did not believe that this was going to be the answer. I believed that the answer to this was actually, and now I'm going to put some approximations here, 0.025. Why did I believe that the answer was 0.025? Well, because this is a normal distribution, and an IQ of 130 is 2 standard deviations above the mean, so a z-score of 2. And I believe that the area under the curve between -2 and 2 of z is 0.95, which means that this area and this area together is 0.05, which means that this area by itself is 0.02. Now, of course, as I write all of that out, I realise that, well, of course, it's not exactly 0.025, because this is like a 95% confidence interval, and we know that the z-scores on 95% confidence intervals are not -2 and 2, they're 1.96 and -1.96. Just a little bit of a tangent there. So we use that rule of thumb, that 0.025, 0.95 rule of thumb, but when we actually calculate it, we just get something pretty close to that. Okay, all of that aside, we're ready to solve this now because we know the probability of solving in less than 2 hours. We know the probability of having an IQ greater than 130. So we can now figure out the probability of having an IQ greater than 130 given you can solve it in 2 hours. Okay, that's going to be equal to the probability of having an IQ greater than 130 intersection and solving in 2 hours over the probability of solving in 2 hours. Okay, interesting. Doesn't look like I'm finished yet because I don't know this. I don't know the probability of having an IQ of greater than 130 and solving in 2 hours. So, going back through the question, this information, I haven't used this yet. 80% of people with an IQ greater than 130 can complete the puzzle in less than 2 hours. Okay. So, if the probability of you having an IQ greater than 130 is 0.02275, and the probability of you solving in 2 hours after that fact is 80%, then the probability of you having an IQ greater than 130 and solving it in 2 hours is going to be equal to 80% times 0.02275. I feel like maybe you won't believe me about that, so tree diagram. Alright, there's my little tree diagram. The probability of having a high IQ, larger than 130, we've already figured out is 0.02275, and the probability of having a high IQ and then solving it in less than 2 hours is 0.8. And hopefully you can see that the probability of doing this and this, having a high IQ and solving it less than 2 hours, is going to be this times this. Okay, satisfied. So all that remains now is to put that 0.30103 in from this and calculate that. And we get an answer of 0.060459. You can round however you want. I guess if we go to 4 decimal places, we can put a neat little 5 in here. All right, that is a Tech Active short response question 20. Let's tick them off. So, 2 Tech Actives, 2 Tech Active short responses. We've done 39 questions over these holidays. Now, these videos have been running close to about 24 minutes each, which means that's 240 minutes of video. That's 4 hours. If you've watched all of them, you've watched 4 hours worth of maths these holidays, which is probably an excellent use of your time. So I congratulate you on doing that. Of course, it's just the beginning. What you need to do now is look at all of those skills, but also look at the skills that I've missed. If you can think of a question or a question style or a topic that I didn't cover, put it in the comments, let me know, let others know. It's really up to you now. Maths is not a spectator sport. I'm thankful that you watched these videos, but you've got to do a lot of work now. You, pen, paper, mathsing. All right. Thank you very much. I will catch you in the next one. See you all.